Hello students, welcome to my class. Today we are going to discuss some more concepts on the measurement. Okay, so today we are going to start the class with units of length. Okay, some of these units might be new to you, but don't worry, I am going to explain you all these units in a proper way. Okay, so let us start the class. Students, we will start with the SI unit of length, that is meter, and it is denoted by small m. And how meter has evolved? Meter was defined in 1889 as the distance between two marks drawn on a platinum iridium rod kept at 0 degrees Celsius in the International Bureau of Weights and Measurement at service near Paris. So what is a platinum iridium rod? It is an alloy in which 90% is platinum and 10% is your iridium. So it is defined as the distance between two marks on this rod, okay, which is kept at 0 degrees Celsius, where in International Bureau of Weights and Measurement at service near Paris. And later on in 1983, meter was compared with the speed of light, and it is defined as distance travelled by light in 1/299792458 of a second in air. Students, let us now discuss about the subunits and multiple units of meter. Okay, as you can see in this board, centimeter, millimeter, micrometer or micron and nanometer, these are the subunits of meter. Those are generally in use. And kilometer is the multiple unit of meter which we use. Okay, so centimeter, this is nothing but 1/100th part of a meter, or we can write it as 10 to the power minus 2 meter. Okay, and millimeter, it is 1/1000 of a meter, or we can write it as 10 to the power minus 3 meter. Okay, and 1 centimeter is equal to 10 millimeter. So we can write 1 millimeter as 10 to the power minus 1 centimeter. Okay, it is 1/10 of a centimeter. Micrometer or micron, it is 1 millionth part of a meter, that is 10 to the power minus 6 of a meter. And nanometer, it is 1 billionth part of a meter, that means we can write it as 10 to the power minus 9 meter. Okay, so in this way we can represent. These will help us in conversion of units. Okay, when we go from one unit to other unit, that means higher unit to smaller unit or smaller unit to higher unit, these all things will matter the most. And when we go for the multiple unit of meter, generally we use kilometer. Kilometer is 1 kilometer, that is equal to 1000 meter, or we can write it as 10 to the power 3 meter. So these are the subunits and multiple unit of meter, and we can represent them in the shortest form, that is centimeter can be represented as cm, millimeter is represented as mm, okay, micrometer or micron is represented as mu m, and nanometer is represented as nm, kilometer is represented as km. Okay, so we can write that 1 centimeter, so this can be written as 1 centimeter is equal to 10 to the power minus 2 meter. Same way, millimeter can be represented as 1 millimeter is equal to 10 to the power minus 3 meter. Same way, 1 micron is equal to 10 to the power minus 6 meter. 1 nanometer is equal to 10 to the power minus 9 meter. Okay, so these are the ways to represent the units. Students, we have discussed about the metric units of length, the meter, centimeter, millimeter. Now we are going to discuss about the non-metric units of length. We have discussed that kilometer is the multiple unit of meter. That means it is used to measure long distances. But when we are going to measure the distance between heavenly body, kilometer is too small. In that case, we use non-metric units of length such as astronomical unit, which is represented as a dot, u dot, light year, ly, and parsec. Okay, so we are going to discuss about these units one by one. Students, astronomical unit or AU is equal to the mean distance between the earth and the sun. Okay, and one astronomical unit is equal to 1.496 into 10 to the power 11 meters. Okay, you need to remember this, that one astronomical unit is equal to 1.496 into 10 to the power 11 meter. You need to remember the relationship between astronomical unit and meter to answer any questions related to the distance between earth and sun. Okay, students, let us now discuss about light year. Light year, which is represented as ly, it is the distance travelled by light in 1 year. We know that the speed of light is 3 into 10 to the power 8 meter per second, or we can write at meter second to the power minus 1. So 1 year, that is 365 days. So we need to convert it into seconds. So 365, 1 day is 24 hours and 1 hour is 3600 seconds. So these many seconds. Okay, because it is meter per second, so we need to multiply it with these many seconds. So when we calculate, we get the value 9.46 into 10 to the power 15 meter. So let us convert it into kilometers. So 1 meter is equal to 10 to the power minus 3 kilometer. Okay, so to convert it into kilometer, we need to multiply it with 10 to the power minus 3. So that gives us 9.46 into 10 to the power 15 into 10 to the power minus 3. So 15 plus minus 3, that is 12. So 9.46 into 10 to the power 12 kilometer. So the value of light year is 9.46 into 10 to the power 15 meter, or it is 9.46 into 10 to the power 12 kilometer. Okay, students, distance of stars from the earth is measured in light year. However, we have some smaller units of light year which we use as and when required. Those are light minute and light second. Okay, so 1 light minute is equal to 3.8 into 10 to the power 8 into 60. Why? 3.8 into 10 to the power 8 is the speed of light. So in 60 seconds. So when we calculate this, we get 1.8 into 10 to the power 10 meter per second, or we can write it as 1.8 into 10 to the power 10 meter second to the power minus 1. Okay, so light second, 1 light second is equal to 3.8 into 10 to the power 8, which is the speed of light, into 1 second. So it gives us 3.8 into 10 to the power 8 meter per second. Okay, just need to remember these values so that you can use them as and when required. Okay, students, let us now discuss about parsec. What is parsec? 1 parsec is the distance from where the semi-major axis of earth, that is 1 AU, subtends an angle of 1 second of arc at the center of sun. 1 parsec is 3.26 times the light year. Whew. Isn't it a bit critical? Don't worry, we are going to discuss it in detail. See, because there are so many things, new things for you. That is arc, 1 second of arc, or it is also called arc second. Okay, arc second, or it is written as arc sec. Fine, and semi-major axis and many more. And I am going to explain everything to you so that you can have a clear vision about parsec. Okay, students, let us now simplify the definition of parsec. Okay, the distance of 1 parsec used to be defined as the distance from the sun at which the radius of the earth's orbit subtends an angle of 1 arc second. So suppose sun is over here and this is the orbit of the earth. So this is the radius of the earth from center to the orbit. Okay. So suppose the position of earth is over here. So in that condition, suppose there is a star somewhere and it is subtending an angle of 1 arcsecond. That means if we draw an angle with the orbit of the earth, or you can say the radius of the earth's orbit, then that angular value should be 1 arc second. Okay, then the distance of the star from sun, it is called 1 parsec. Hope you understand. Students, we are going to discuss about some smaller units of length. Those are Armstrong and Fermi. Armstrong is used to measure the wavelength of light, intermolecular separation between the atoms, etc. And its value is 10 to the power minus 10 meter. And it is represented by this symbol. Okay. And there is another unit, that is micron. That is 10,000 Armstrong. And nowadays Armstrong is actually obsolete. We don't use Armstrong, but we use nanometer instead, which value is 10 Armstrong. Okay. So nanometer is used instead of Armstrong nowadays. And Fermi is used to represent the size of the nucleus. Size of the nucleus. Okay. It is equal to 10 to the power minus 15 meter. Okay. So these are the relationship between various smaller units of length with the SI unit, that is meter. You just need to remember the relationships. Okay. Students, let us now discuss about units of mass. Okay. SI unit of mass, as we know, that is kilogram. And in 1889, 1 kilogram was defined as the mass of a cylindrical piece of platinum iridium alloy kept in International Bureau of Weights and Measurement. Where is it located? We have already discussed about it. Yes, you got it right. It is located at Servais near Paris. Okay. Students, the latest definition of mass with effect from 20th May 2019 defines mass in terms of a fundamental value called the Planck's constant. Okay, Planck's constant, which has the value of 6.62607015 into 10 to the power minus 34 kg meter square per second. The Kibble balance, which makes use of the Planck's constant, measures the mass of an object. You need to remember, the mass of an object is measured using a precisely measured electromagnetic force. Since we have discussed that 1 kilogram was defined in 1889 as the mass of a platinum iridium cylinder, which is a physical object, and it can be lost, it can be damaged and whatsoever. So what will happen to the kilogram then? And it has been observed that the mass of that particular cylinder is fluctuating. That is why scientists, they came up with a solution of a fundamental constant which is not going to change, and using this Planck's constant, mass of an object can be measured precisely. Okay, you need to remember this. Students, gram and milligram are two subunits of kilogram which we generally use. Okay, so 1 kilogram is equal to 1000 gram, or we can say that 1 gram is equal to 1 by 1000 kilogram, or we can write 10 to the power minus 3 kilogram. So this is the relationship between gram and kilogram. Same way milligram, 1 gram is equal to 1000 milligram and 1 kg is equal to 1000 gram. So 1 kg is equal to 1000 into 1000, that is equal to 10 lakh milligram. Okay, or we can write it at 10 to the power 6 milligram. So 1 milligram is equal to 10 to the power minus 6 kg. So 1 milligram is equal to 10 to the power minus 3 gram, or you can say 1 milligram is equal to 10 to the power minus 6 kg. So we need to remember this relationship between the SI unit and its subunits so that we can represent or use them as and when required. Okay? Students, let us now discuss some multiple units of kilogram. Okay? So multiple units of kilogram, those we commonly used are quintal and metric ton. Okay? So quintal is nothing but 100 kg. So 1 quintal is equal to 100 kg and 1 metric ton is equal to 1000 kg. That is equal to 10 quintals. Okay. You might have heard about 100 metric ton of iron, 10 quintal of rice. So in that way we use such multiple units of kilogram. Okay. Students, let us now discuss about a non-metric unit of mass, that is atomic mass unit, or it is represented as AMU, or it is also called as unified atomic mass unit, or U. Okay, so how can we define 1 AMU? 1 AMU or 1 U is 1/12 the mass of a carbon 12 atom. Okay, if we take a carbon 12 atom and 1 AMU means it is the mass of 1/12 of that carbon 12 atom. So let us find out the value of 1 AMU. Okay, students, the mass of 6.02 into 10 to the power 26 atoms of carbon 12 is equal to 12 kg. So what should be the mass of one atom? One atom of carbon 12 is equal to 12 divided by 6.02 into 10 to the power 26. So 1 by 12th, so 1 AMU, that is 1 by 12 of this value. So that is equal to 1 by 12 into 12 by 6.02 into 10 to the power 26. Okay, so when we calculate this, 1 AMU gives us the value as 1.66 into 10 to the power minus 27. So 1 AMU is equal to 1.66 into 10 to the power minus 27 kilogram. Okay, hope you understand. To find out the value of heavenly bodies, we use a unit, that is solar mass. What is a solar mass? It is actually mass of sun. Mass of sun. So, one solar mass has the value of 2 into 10 to the power 30 kg. Okay? You need to remember this value, that one solar mass is equal to 2 into 10 to the power 30 kg. Okay? Students, today you have learned some more concepts about measurements. Hope you have understood everything clearly. If not, please watch the video again. Go through the book and read out everything properly. Okay? So, as I always say, keep revising, keep practicing, and most importantly, keep smiling.